Hello and welcome to Course 3, Advanced Lessons in CodeJumper. This is Lesson 14, Nested Loops. So, overview, the objectives are students will understand what a nested loop is and be able to develop programs that use nested loops. The expected outcomes are that all students will be able to state that a nested loop is a loop inside another loop. Most students will be able to create a program that uses nested loops, and some students will be able to create a program that uses nested loops and counters. So our key vocabulary. We've seen loop before, back in the beginning lessons, and it's a way to organize commands in a computer program so they repeat a sequence of instructions or actions a required number of times. A nested loop is a loop within another loop where the entire sequence of instructions or actions is repeated. So what does this look like? We'll start with our unplugged. And so this is just the beginnings of that understanding of what a nested loop is. And what we're going to be using is real-world examples of nested loops, and then students can choose one example that they like and write about it in their computer science journal. And then we'll look at the materials that we'll be using in this lesson. So on the screen, I have a picture of 3 different objects. I have a clock with an hour, minute, and second hand, and I have a picture of a stopwatch with a minute hand, and a picture of the world. So how do these relate to a nested loop? Well, if we think about a loop, something that goes around and around again, it repeats. A clock, it does that, and the nested part is so when the clock goes around, we have each hour 1 through 12 or 1 through 24, and it goes around again and again every single day. But we not only have the hours 1 through 12 or 1 through 24, but we have the minutes. Every hour is a 60 minutes, so that's the second loop that's going along. And inside of that, we also have the second hand going inside. So all day long, we're having this loop of hours, minutes, and seconds going around and around as we go through our day. A stopwatch is the same thing. We have a minute hand going around and around, but then inside, sometimes we have these little tiny second hands that are also going around inside, around and around again. The world is actually even a series of nested loops if we think about it. We have the planet. The planet is turning all the time. It's always rotating. But then we have our tides that are moving around the earth. We have all these different little things that are moving in loops again and again all day long. It's spinning, and then we have time, and then we have tides, and we have all these different things that are constantly moving all within this sphere of the world. So students can take those, they can take these pictures, they can color them, they can put stickers on them, or they can take their own and then put it inside their computer science journal and write about what that nested loop actually means. So then we'll take that and go into our guided activity. So we're going to be able to create a program that using nested loops. This is one that is good to show your students, work on it next to side by side, or however you want to do that. This is a great program to start with for nested loops. So what we're going to need is our kit, our hub, play pods, the loop pods, the new one of the extension cord, which looks just like an extension cord. I'll be showing that in a minute. And we have 2 different code cards, one with count with notes, count with melody. We're just going to be doing the counting with notes right now. But I would say go explore the counting melody one as well. Okay, so on the screen right now, I have a screen grab of the block coding we see from the app and a picture of what the program looks like. So we have the hub attached to a loop pod, which is attached to a second loop pod, which is then attached to a play pod and then a second play pod. That loop is closed up, and then that first loop is closed up around the outside. So we have a self-contained loop inside of this bigger loop, which is why we need to use the extender cable. But let's look at this app, the block coding and the code card, and kind of think about this. So we have 2 play pods. So we're going to be hearing 2 sounds. And that is inside that loop that's telling us to play it 3 times. And then that loop is the outside loop is then telling us to play that inside loop 4 times. So let's jump over to the app and to the camera so we can see it in action. So I have the hub, my 2 loop pods, my inside loop with the 2 play pods. I'm going to read the code so we can hear how it sounds with all of these loops.
Thread 1 piano. Loop 4 times. Loop 3 times. Play E5 for 1 beat. Play F5 for 1 beat. End loop. End loop. End thread.
Okay, so we have that loop inside of a loop. Now let's talk about the math of it, and this is where it gets interesting. So inside this loop, we have 2 sounds, and it's telling us to play that 3 times. So every time it goes around, we'll play 6 sounds. So for that inside, but every time we're gonna have to do that 4 times. So those 6 sounds are gonna be played 4 times. So we should hear 24 sounds. I would suggest having the sounds on each of the sound dials different, because then you can hear those pairs of those sounds that are in that first loop and be able to kind of count. One way to keep track is just like we did in the other lesson when we were doing the tally marks for the counters. I say do that again. Get a piece of paper or use your computer and just pick a key, and every time you hear a sound, make a mark. Then you can count how many times that goes around. So let's give it a play and see what it sounds like. It sounded a little ominous, but we had 24 notes that we heard, 12 of each note. So I'll give your students time to just explore this and see if they can figure out how many times each note is playing. So that's our guided lesson for the nested loops. Okay, so now let's look at the exploration. Students will create a nested loop program that contains at least 18 total sounds using only 3 pods, 3 play pods. So a nested loop. So for this one, students should only have at their disposal the computer, their hub, and 3 play pods and the 2 loop pods. That's all they should have. Okay, so let's build it and see what we can do in to make 18 sounds. Okay, so I have a program up right now where I have 3 play pods inside of a loop, inside of a loop. So I have the hub attached to a loop pod, attached to a second loop pod, and inside that second loop pod, I have 3 play pods, and then that outside loop is closed up. So let's listen to the code.
Thread 1 piano. Loop 3 times. Loop 2 times. Play E5 for 1 beat. Play C6 for 1 beat. Play F5 for 1 beat. End loop. End loop. End thread.
All right, so that is our program. So let's play it and see how many sounds we should hear. So take a moment, pause the video, and thinking about how many sounds do you think we will hear, and then tally them, write them down, or just follow along. So I'll press play right now. All right, hopefully you got your number down. Now let's look at the math of this. So on my slide, my next slide, I have it all written out in a lovely math equation. So I have 3 open parentheses, 2 times 3, close parentheses, equals 18. Now let's break this down of how this applies to CoJumper. So inside we have this 2 times 3. That's our inside loop. So every time it goes around, we're going to hear these 3 sounds twice. So 1, 2, 3 times 2 is 6. And then our loop said to go 3 times of that inside loop. So then we need to multiply by that 3. So we should hear 18 times. So depending on your student's age and their level, you can take it into this deep of math, but this is just a good way to look at it and understand for yourself as well of how this loop works and what does it actually look like. So that's what we have for our lesson on nested loops. Thank you and look forward to next time.